In this screencast, we are going to talk about writing equations. So for example, you'll see the equation written on the screen where you have your $150 times your number of people equals your total cost. So let's go ahead and look at problem 3.1. This is going to kind of introduce writing equations. So go ahead and read the screen. This is just looking at visiting Wild World Amusement Park. So once again, going along with our ocean bike tourist trip. And one of the destinations that they are going to. So two key questions in this problem say what variables would affect the cost of the amusement park trip and how would those variables affect the cost. So if you look at our information that Malcolm found, it says that it costs $21 per person to visit Wild World, and that Malcolm's come up with a rule, which is kind of our definition of an equation. An equation is a rule for calculating the cost. So he says that the cost in dollars is equal to 21 times the number of people. So you can see, and we kind of know that because it does say $21 per person. You'll notice that when he goes to write the rule or the equation, he just pulls out that important information. So he has his cost is equal to 21 times the number of people. The 21 in this particular problem is our constant rate of change because it's always going to be $21 per person. So looking ahead, you'll see that here's Malcolm's original sentence, number sentence, or equation, because it has an equal sign. And Liz says that she can shorten this by just using single letters. So when you think about algebra, a lot of times we think about letters. So notice that Liz used the letter C for cost. The 21 stays the same because once again, that is your constant rate of change. And then she used N for the number of people. If you think back to when we were working in our geometry unit, we started to talk about what does it mean when we have a number next to a letter. And what that means is that we are multiplying. So 21n means 21 times n. So really, this is the shortest equation that you can write. And this just means that if we gave you the number of people, or n, and we said that we wanted to figure out the cost for 10 people, all you would do is fill out your equation because you're still finding cost. So C would be equal to 21 times 10. Once you multiply, you would get $210. So in order to get 21 people into Wild World Amusement Park, it would cost $210. So using an equation just allows you to substitute or find the value of the dependent variable whenever you are substituting in for the independent variable. So there are a few vocabulary terms that we're going to introduce in this particular problem. The first vocabulary word is just the word expression. The word expression is basically part of the equation minus the equal sign. So our original equation looked like this, C equals 21n. The expression part is just this 21n, okay, not including the equal sign. So 21 times n is going to be our expression. The next vocabulary term is equation, and we talked about this a little bit. Your equation is the one with the equal sign in it. So in this example down here, this whole thing that I am boxing in red is going to be our equation, the C equals 21 times n. And then you'll see the last word, which we will use sometimes in class but not as much, is the word coefficient. And coefficient is just the number that comes in front of the variable. So in this example, 21 would be our coefficient. So this just says the equation C equals 21n involves one calculation. You multiply the number of customers, or n, by the cost per customer, which is $21. Let's take a look at an example. This example says the Ocean Bike Tours found that it would cost them $150 per person to go on the bike tour and cover expenses. Write an equation that calculates the total cost for any amount of people. So let's go ahead and just highlight some important things. So if I look up here, if I'm going to highlight $150 per person. I'm going to highlight the part where it says calculate the total cost for any amount of people. Okay, so right now I need to figure out what is my independent variable and what is my dependent variable. So I have total cost and I have amount of people. Well, my amount of people is controlling the total cost, so amount of people would be my independent variable and total cost would be my dependent variable. $150 per person would be my constant rate of change because each person that I add the cost would go up by $150. So if I take a look, I'm finding total cost, so that's going to be on one side of my equation. So total cost equals $150 times the number of people. So we want to try to shorten this as much as we can. So we are going to change total cost into C. $150 stays the same because that's our constant rate of change. And then we're going to change number of people into P. If we shorten this a little bit more, we would get C equals 150 P. And that would be our final equation. We could substitute any amount of people into this equation and find our total cost. Let's take a look at one more example. This example says that Nick is driving at a constant speed of 60 miles per hour. Write an equation to find how many miles he drove after any number of hours. So once again, if we highlight some important information, we know that we're going at a constant speed of 60 miles per hour. We're writing an equation to find how many miles he drove after any number of hours. So we're trying to calculate miles and number of hours. 60 is going to be our constant rate of change because we see that word constant speed. So once again, if we're looking at total miles, that is going to be our dependent variable because the total miles depends on how many hours he's driving. So then we're going to take 60 miles per hour and multiply that times the number of hours. So let's go ahead and change our variables. Total miles we could change into T. You could also use the letter M. 60 is going to stay the same. Hours, I would use H. So I might actually change T so that it's an M, just so that we're not getting like time and total mixed up. So we have number of hours and 60. Once again, to shorten this, we could do M equals 60H. So if I told you that Nick drove for 3 hours, you would take this information, substitute it in for H. So M equals 60 times 3. So his total miles that he traveled would be 180 miles. So that's how you would use that equation. So this is just kind of a brief overview of problem 3.1 and how you would set up writing equations using one variable.